lecture 11. Today, sorry, voice compression technology is explained. This compression means reduced transmission bit rate. So generally, by the sampling theorem, for voice transmission, 64 kilobit per second transmission bit rate. However, by using some technology, we can reduce the transmission bit rate very much. This is introduction. Data compression, also called compaction. The process of reducing the amount of data needed for storage or transmission of a given piece of information, typically by the use of encoding techniques. In the case of voice voice signal, redundant information is included. So by using the essential characteristic of voice, the redundant part are deleted and data compression can be achieved. Today, when uncompressed digital signal may require 96 megabytes, data compression is important in storing information digitally on computer disk and in transmitting it over communication networks. So in the case of voice, 64 kilobit. However, for the digital image transmission, 96 megabytes, almost 1,000 times larger than the voice. So compression technology is used. So, however, today the voice compression only explained, and next week the digital image compression will be explained. The process of data compression is shown in figure 1. The original message is compressed by encoder and transmitted. In the receiving side, the complex signal is converted to the original signal by decoder. This transmission part becomes low bit rate. So in your handy phone, some effective coder is implemented. So from now, I will explain many technologies. First of all, bit rate of voice in digital communication is shown here. So already you know this process. So analog signal is input. Then a sampling theorem is used, and if analog signal is has a bandwidth of 4 kHz, this is usually used bandwidth for the voice. Then sampling theorem require sampling frequency of 2 times of highest frequency of voice. So it becomes sampling frequency become 8 kilohertz. Sampling frequencies this frequency. So original signal is sampled by 8 kilohertz speed. Next, so 8-bit coding can be used to the amplitude of voice signal to express this amplitude. 8-bit coding is used. So bit rate become 8 kilohertz multiplied by 8 bit. So 64 kilobit per second transmission speed is needed. So like this, amplitude is expressed by 8-bit pulse. So this is the converted analog to digital converted voice. So usually this 64 kilobit per second pulses are modulated ASK, PSK, FSK, and transmit. So this is the process to send the analog voice by the digital signals. So one more thing. So in here, the bit rate become 64 kilobit per second. That is important information. And one more information is when this 1 bit is Fourier transform. Fourier transform is expressed by E minus j omega t. That is Fourier. This amplitude is equal, consider 1. So Fourier transform equation become this one. So we calculate this integral. This becomes minus 1 divided by j omega. The summation upper half p. Then like this, and finally the Fourier transform value become like this, phi ft times phi ft. So this is called very famous function. This is called sampling function. So this figure become like this. The frequency, this horizontal line is frequency that starts from 0 to plus and minus. And the first 0 point at frequency 0, this become maximum. And at 1 divided by t, then this sign inside the sign, this becomes pi. So sine pi equals there. So next 0 point is 2 divided by t. So if we transmit this one by FDTD, must 64 kilobit separation. So compared to the analog, in the case of FDTD, this is 4 kilohertz basic. So this is very large bandwidth is separated. Capacity in the limited 60 per requesting. This is mainly by the operator of communication system. So next is practical method. Voice compression technology. This is the table one, compression of voice codec. Waveform coding, frequency domain, hybrid coding, and analysis and combining coder. This is very reduction rate is very high. So these are called vocoder. Vocoder is voice coder. This is most frequently used. So sometimes simplify these technologies are called vocoder. So this is the transmission rate. The waveform coding, that is transmission bit rate become 12, the minimum 12, the maximum is more higher. So waveform coding, frequency domain is minimum is 12, and higher is more high. And hybrid coding, the minimum bit rate is 4.8 bit per second. So finally, analysis and combining encoder. This is only 0.4 to 4.8 bit. This is most effective method. This is a complexity. This is complexity low, not so complex procedure. So in the waveform frequency domain, in this case, this frequency domain to obtain frequency domain, the Fourier transform is needed. So the complexity becomes medium. The final two, hybrid coding and analysis and this coding, the procedure is more higher. So complexity is higher. However, higher complexity the transmission bit rate is very you is 64. In this technology, around 12, 4.8, and very low rate transmission is. So for this auditing, the ADPCM, this is most typical. And frequency domain SBC technology is typical. And hybrid CELP, self, and host technology LPC. These are very typical. So from now, I will explain each method. And here, the method of 3 and 4 is now using handy phone. So some almost 1/10 of the general transmission. So I start explain ADPCM. This is the explanation of ADPCM. So ADPCM is adaptive differential PCM, adaptive differential. So this means this is the original analog signal. So this waveform, in order to transmit this waveform, a small slope information delta S is used to transmit data. To achieve to transmit to determine this slope value, these processes need. First of all, adaptive prediction. In this prediction, obtain differential data of level. This level is obtained in this process. And another is optimization of time step. This delta T. So by determining delta T adequately, we can obtain the difference level difference. So from this delta T and delta L, we can understand a slope of delta S. So delta S is obtained. The slope data is sent like this. Only slope is sent. So compared to the original sampling value, this sampling value is very large. Amplitude is large. So 8-bit is needed to digitize this amplitude. However, in the case of slope data, the amplitude becomes small. So only 4-bit can be sufficient for digitizing the amplitude. So here, digitization is 4-bit is sufficient. Amplitude of drop becomes smaller. So 4-bit digitization. So another information is this determine adequately P, delta P, the differential data frequency, the frequency of delta L become almost 3 kilohertz. In the sampling theorem, the sampling is 8 kilohertz, so this can be reduced by multiplying 3 and 4. The final transmission rate becomes 12 kilobit per second. Here, voice quality is maintained. If this coding, voice quality is degraded, that is no good. However, the information slope is used. So this analog signal waveform is not deformed. Very correctly, the waveform is changed to the slope combination. So, as a conclusion of this method, essential of time domain waveform is a slope of curve. So, the waveform essential is not this shape. Each slope slope value is the essential point of the waveform. You can understand the waveform is total shape. However, the main, the most important thing is the slope. Slope is by changing of slope. This shape is achieved. So only slope data transmission, that is same as this waveform transmission. However, like this, the amplitude reduced and the frequency reduced. The transmission bit rate can be reduced from 64 to 12 bit. You can understand this method. So next is frequency domain method. So to obtain the frequency domain information, the original signal is Fourier transformed. We consider this is a Fourier transform waveform. The horizontal axis becomes frequency. The process is almost the same, and at this point, select the frequency separation step, and this adaptive prediction part obtain the level difference. So, in the frequency domain, the shape waveform slope is also obtained. So say, are the same. this large amplitude is converted to small amplitude. So bit rate is reduced under almost same manner. The data signal become 12 kilobit per second. In this case, the Fourier transform simply is not deformed, so voice quality is maintained. Here, the essential of frequency domain waveform, slope of the curve. This is also the previous and this time is different. Only time is converted to frequency. The shape information is the important parameter of this shape is the slope. So important information is transmitted. That is same as the wave transmission. However, slope transmission reduces the transmission velocity to 12 kilobit per second. Next, method of CELP. The CLP is forward excited linear prediction method. So this is based on the our human voice production. Our voice is produced by the vibrating film at the throat of our body. And this air duct continue to the mouth and the tongue. So this the function of vibrating film is produce the many frequency component. That is same as white noise. And breathing, our breath determine the strength of the frequency source. This is a frequency. And this, our mouth and the tongue works like a filter. This filter selects special frequency component. So the mouth opening and tongue position determines the filter. The essential part of human voice is voice source and the filter. So in the pronunciation textbook, many pronounce A, B, C. Then we must use the tongue adequately. So the opening of mouth and the tongue position determines the voice. So we can understand this part filter, and this is the voice source. is compose the voice signal. So based on this understanding, we can make transmission method. So this shows a transmission method. This is called voice code book. So filter is many types prepared, and the strengths also many types. So combination of strength and filter pattern, then we can make this is R. And another combination E, and another combination A. This is U, M, K, Ku, Mu. The sound is Mu. This sound is Ku, and this sound is O. Hence, thank you is produced TH A N K U by combining the each combination. We can make some sound. The voice is composed vowel. Vowel is R, E, A, U, O, and a consonant is M, K, and some another. So combination of this by using this output, any voice element voice can be produced. So in this case, not the voice itself is not sent. The combination of AI and FI are transmitted in order to produce the same waveform with voice. The purpose of selecting the filter pattern and amplitude is produce the same waveform. If this is a R waveform, then this combination achieves the same waveform. E waveform is different. So the purpose of selecting filter pattern and noise pattern is to make the same waveform. So to achieve waveform is rather complex process. So like this, this is the methodology shown. Voice signal is linear predicted. Then compared to the code book, AI and FI and the same waveform is synthesized here. However, the information of AI, FI is very small information. So transmission bit rate becomes 4.8 kilobits per second. Compared to the previous 12 kilobits per second, this speed is smaller. However, in this case, almost the same waveform for the original voice is the purpose. So not so much reduction is not achieved. The essential, the important point is summarized here. By using essential feature of voice, that is a noise, voice source, and the filter type. By obtaining this information, data compression is achieved. The bit rate is reduced to 4.8. However, in this case, the purpose is to achieve the same waveform. So at the most, this bit rate is smallest. Next, this is the final method, LPC, linear prediction coding. That is almost similar. However, the purpose of code book is not the waveform. Sound, voice sound. That similar voice sound is produced is this method. So sound is judged by ear. So this is our ear can distinguish sound. If a little bit sound is bad, our ear can recognize what sound is. And so this is more more for the transmission side. This is more roughly transmit. So to achieve voice sound, the different and more simple code book is used because the sound anticipation is not so strict. Our ear can distinguish the sound if the sound is not so clear. So more simple code book is possible. So to use to produce the same sound with voice. So another feature is voice sound is more similar to the natural voice. That is judged by ear, so it seems more natural. So by using essential feature of voice, like AI and FI, data compression. So based on the sound, the bit rate is reduced the minimum 0.8 kilobit per second. The upper is only 4.8 per second. So the data compression rate is most large in this method. So the key function of this LPC is to achieve sound similar to the voice. The same sound. This is the waveform. So to achieve the same waveform is rather difficult. However, to achieve same sound is rather easy. So like this different for the book is prepared in the LPC method. Do you understand this explanation?
Yes, Sensei.
Okay. So this time for voice compression, I prepare only this slide. So explanation is finished. Do you have any question for the method of coding?
No, Sensei.
Okay.
Okay, Sensei.
Okay.
Okay, then I would like to give report. This is the same as table here, table 1. However, the content is different. Essence of compression will be explained here. The waveform coding of time domain. That is a slope, small slope signal is used. So by the use of slope, the transmission rate is reduced. So essence of compression is slope detection, slope use. Okay, and the example is something for frequency domain also maybe slope, and hybrid coding is something waveform by voice element, filter, and voice strength. So this is not waveform, this is sound voice. Like this, you consider one by one these explanations. So if what is you understand the essence of compression. So describe all method and show some typical coding name. You can understand this question.
Yes, Sensei.
So this is level 3. Please explain all methods by your understanding. Okay, if you understand this question, then I would like to finish today's lecture.
Okay.
Okay,
Sensei.
Yeah.
Okay.
Do you have some question? How to answer? No question.
No question, Sensei.
Okay, then study by yourself each method and find out essential point of each coding. So I will
Okay,
expect
Sensei.
your this may be good practice for you to understand each coding. Okay, I will waiting your original and unique expression.
Okay, okay.
Okay.
Okay, sensei.
Then I would like to finish today's lecture.
Okay, thank you,
So
Sensei.
maybe we meet next Monday. So till that, please take care your
You
health.
too, sensei.
Okay, bye.
Okay, bye. Thank you, Sensei.
Bye. Bye. Thank you, sensei.
Okay.
Bye, Sensei.
Okay, bye.
Sensei.
Bye.